Please like, share, and subscribe.
Check to see how much interest the loan gained. So we know that he took out the amount, $250,000, right? So we just want to know how much interest it gained because he didn't pay for it for the first 2 months. See that? So we know that he missed out on repaying it for 2 months, and interest was charged at 15%. And this is compounded monthly. The term is monthly, it's 12 then. So the trick here is to convert I, because 2 is already, n rather, is already known to be 2. So the way you convert I is that you will have the percentage, all right, divided by 100 multiplied by 1 divided by the term. So for this example, I will just be 15 divided by 100 multiplied by 1 over 12, which is 15 out of 1,200. Now you can leave it in fraction form, but I actually prefer decimal form, and that's going to be 0.0125. That's my value of I. So I can just go into the formula, future value equals present value into 1 plus, this is not compound interest formula. I'll go ahead and substitute these answers and see what I get. 0.125 to the power 2. So Tabiso will then owe the bank an extra 6,289 rands because of the 2 months that he missed out on. So the value of the loan is no longer $250,000, but is now at 256,289.0625 cents. So that's the value of the loan after having missed out on 2 payments. Looking for his monthly installments, and the formula to be used here will have to be the present value formula, x into 1 minus 1 plus I to the power negative n all over I. This is the formula to be used. So let's just understand the question. So first and foremost, we now know that the value of the loan is no longer $250,000, but is at 256,289 and 0.625 cents. I prefer writing it in full. We'll round off the final solution. So the question demands that we find the monthly installments. Given that he's now paid the first monthly installment on the 1st of September, that means initially he was supposed to have paid the loan for 4 years. Given that this term was monthly, we could have had a monthly installment number, meaning 48 installments in total, but now he missed out on 2. So that means we now calculate for 46 monthly installments. See that? So now what happens is I is still valued at 0.0125. So with all this information now, we will go ahead and substitute this into the formula to see what we get. So if you choose, you could have this as your subject of the formula, or you could just leave it there and do the math later. But I prefer having it as subject of the formula. Just gonna unbox this information here. So I'll have PV multiplied by I equals X into 1 minus 1 plus I power minus N. Divide both sides by that, making X subject to the formula. Right. So now X will be 256,289.0625 0.0625 multiplied by I, which is 0.0125, all over 1 minus 1 plus 0.0125 to the power minus n, which is now minus 46. And the answer would be, just get my calculator quickly, and that will be 7,359.79. So that means you'll be paying this much every month for the next 46 installments. Looking for the duration now to see how much sooner I will be able to repay the loan, given that he's now paying monthly installments of 9 grand, where the value of the loan is still 256,289.0625 cents. We now want to know how long he'll be paying this much. Will it take him to pay off the loan? Well, the interest is still at 0.0125. Okay, so we still use the formula PVX 1 minus 1 plus I power minus n all over I. So I can just substitute all these values here. So I'm going to have 256,289.0625 equals 9,000. 1 minus 1 plus 0.0125 to the power minus n, which is what I'm looking for. I'm going to divide that by 0.0125. Cross multiply this, multiply by that. Right. So it's going to be a little hefty, so I'm just going to cross multiply. I'm going to have 256,289.0625 multiplied by the denominator there, 0.0125, and I'm going to divide that by the 9,000 there, and that's going to be equated to this square bracket here, 1 minus 1 plus 0.0125 power minus n. Right, you see from here, all you do is you're gonna have that as simplified to be 700. Let's move on to this side. I'm gonna try to squeeze as much space out of this as I can. So I'm gonna have this whole thing simplified to 729 divided by 2048. That's not equated to 1 minus the sum there, which is 1.0125 to the power minus n. Not forgetting that that's all we're actually looking for. So I'm gonna have I'm just gonna switch the 2 up. All right, let's switch the 2 up. I'm gonna have 1.0125 power minus n equals 1 minus 729 out of 2048. And that's going to be simplified to be 1,319 divided by 2048. Now, laws of exponents, to have that as a positive exponent, I'm going to have it as a denominator. So 1 over 1.0125 to the power n equated to that thing there, 1319 over 2048. I'm still looking for n, cross multiply. So 1319 multiplied by 1,0125 power n equals that multiplied by 1, which is 2048. Divide both sides by 1319 to see what you get. That's going to be 1.0125 power n. You could leave that as it is, I guess, and just use logs to get your answer. So that's going to be 2048 over 1319. So for me to get to n, I'll use logs. So my base there, 0.125 into that whole fraction there, 2048 divided by 1319, and the exact answer is 35.41872,611. But to account for the decimal, because this is actually months, we want the solution to be in months, we'll just round this off to an extra 1. So this will be 36 basically. So we now want to know how many years are in 36, and that's going to be 2 years and 11 months. So in other words, instead of paying off the loan in 46 installments, he's going to do it in 36 installments, making it 10 months sooner. So meaning the entire loan, given that he will now be paying 9,000 rands a month, right, that extra money that he'll be paying will mean that he will finish 10 months sooner. So he'll be able to pay off the loan 10 months sooner. Amount of loan, okay, in its compound interest form, and you're going to subtract the monthly installments that he makes. But you're going to treat these monthly installments as an investment. Okay, and then the answer that you get must be treated like an investment that will only last for a single month. So it's going to be in compound interest basically. So the solution will be compounded for a month. And that's exactly what I'll be showing you shortly. So the value of the loan was valued at 256,289.0625. Okay, so remember now, he was supposed to make 36 installments. However, we're going to calculate the last one. So this means that the value of the loan will be calculated at 35 and not 36, because 35 is the second last number to 36. So this will be 1 plus 0.0125 to the power 35 minus, like I said before, you're going to treat the 9,000 as a monthly installment of an investment. So that's going to be 1 plus 0.0125 to the power n, which is still 35, minus 1 all over I, which is 0.0125. The answer there will be 3,735.45. Remember, I said you take the answer, which is you treat that like a normal monthly installment. So rather, future value will be 3,735.45 into 1 plus 0.0125 to the power of 1. And the answer to that will be 3,782.14 cents. And that's basically how much you'll be paying on his last trip to the bank.